Hello friends, here I am Somen and today we are gonna talk about difference between mass moment of inertia and area moment of inertia. Actually to make this video my friend Abhijay suggested me because many of people have confusion in both of them and in internet you may not find very much description about the difference between both of them. Okay, then let's see. First of all, when we talk about moment, then what is moment? Many of the Mac guys get confused that that might be some kind of romantic moment. It's not like that. Let's see what is it. Moment is something with respect to a fixed reference point or any reference axis. It is very much like this. I have drawn it. When any object is moving in circular path with some momentum, linear momentum, and there is some radius about the circular path, then we get the moment that is upward side. This is something like right hand screw rule. We get moment when we do multiplication of linear momentum and radius. Similarly, we get torque when we do multiplication of force and radius. It is some like that. Then let's see the difference, the definition. In mass moment of inertia, the body in which mass is defined, and in area moment of inertia, the body in which cross section area is defined and is same throughout the body. Actually, mass moment of inertia, we take the mass as defined like this. Over here you can see, first of all, we take a body with some kind of mass which is defined, which we have the mass. Then take a portion dm, and with respect to it some x-axis and with some distance y. Then when we take moment around it, then we get dm multiplied by y. And similarly over here, when we take any body with some cross section area dA, okay, and the distance from the x-axis is y, and when we take the moment of area around this x-axis, then we get dA multiplied by y. And now when we take second moment of area, that means this equation we got, and we are doing it another time moment, then we multiply by y again. Over here also multiply by y again. Now this is we got second moment of area for this portion, this thin portion, okay, and here also. Now if we want to get the second moment of mass and second moment of area for the whole body, we need to get integrated. So here when we integrate them, then we get the whole over here mass moment of inertia and over here area moment of inertia. Okay, then what are the SI unit of them? Here you can see there is a mass, and there are two y's, I mean to say y square, that means that might be meter square. Then we get kg meter square, and over here area is also meter square and y are here square, then we get meter raised to 4. Okay, then what are the difference in the perpendicular theorem if we want to calculate? Then in perpendicular difference there is no difference, okay, but in parallel theorem we get a difference. As we said that over here mass is defined, then we get md square, and here area is defined, then we get here ad square. This is the difference between them. And what is this d? Okay, then let's see what is this d. D is perpendicular distance from axis passing through CG, or I can say center of mass. And over here what is d? D is the perpendicular distance from axis passing through GC, that means geometric center, or we can say centroid. Centroid is basically what, in a 2D diagram, here square, if we draw like it, and the center point we get is the centroid. In a triangle also, this is the midpoint. When we draw the line perpendicular to it, then we get a point, sorry, this is not perpendicular, because these points are the midpoint of the edge. The point here we get is called geometric center, and you know CG very well, center of mass. Then take to the next page. Over here, mass moment of inertia, its property written: resist any acceleration or deceleration in rotating mass like flywheels. When any flywheel is moving very fast, and if you apply brakes, it needs some force, and if you apply some acceleration, it also needs some force. And over here, area moment of inertia, it resists deflection in beams or shafts. That if you know, some beams are used in buildings, and even some beams of iron or steels are used in some factories or industries, and that deflects due to the vibrations sometimes. And what I came to know with this research, this is a new point I got, that if the density of the object is uniform, then center of gravity and geometric center both will be the same point. If the density is not uniform, then CG is never equals to geometric center. They will be some far away maybe. And one another thing that I want to tell you friends, that this point, the body is in which mass is defined, and here the body in which area is defined. Why it is so important? Because this point, in mass moment of inertia, if we increase or decrease the area without disturbing its similarity of triangle, then we can apply the formula for this area also and this area also, whatever it increases or decreases. But the similarity of triangle must be conserved. Triangle or square or anything, rectangle, if I say rectangle, then its ratio must be maintained. And over here, let's see, there is some cross section, and this cross section also same, but the length change maybe here L, here 2L, here as the length change, the mass also change. Okay, the mass here is maybe M, or here 4M. The formula we find for this beam is also useful for this beam. We don't need to change the formula. That's why this is important, and we take this point very important, as the body in which mass is defined and the body in which cross section area is defined. So thank you friends.